Fantastic. Welcome, everybody. We're very pleased to have you here today, and we look forward to share with you our journey of Nasdaq moving mission-critical, low-latency workloads to AWS. My name is Mark Murphy. I'm a Senior Vice President at Nasdaq. I'll be joined today by Nate Sammons, Cloud Architect at Nasdaq, and George Smith, Cloud Architect at AWS. Today isn't just about what we're planning to do, but also about what we've done. Since November 7th, over 1 billion messages have flowed through our MRX platform using AWS Outposts, and we're terribly excited about what that means for the future. What I'll share with you today, and Nate and George, will be the why, the how, the lessons learned, and also what's next. And that's truly what I'm excited about, what we have in front of us for the future. Nasdaq is a global technology provider. We power the world's markets. Disruption and pathfinding is in our DNA, and it has been since we launched the first electronic exchange in the world. By delivering world-leading platforms, we improve integrity, transparency, and liquidity to those markets. Nasdaq owns and operates more than 30 exchanges around the world in 10 countries. We also power, with our Nasdaq technology, 130 exchanges around the world. With that comes great responsibility. Responsibility to ensure that we've well architected, we have modern and accessible platforms. I mentioned earlier liquidity. Liquidity is the lifeblood of any marketplace. It's critically important that marketplaces have liquidity. And let me give you a plain example of what I mean by that. Imagine you wanted to trade Nasdaq on a stock market today, but there was no one else there to give you a price or to interact with you. The workflow would break. You wouldn't be able to trade. It's a simple but exaggerated example, but I just wanted to highlight what liquidity means for marketplaces around the world and what Nasdaq and AWS can do together to solve for that problem, particularly in frontier and in emerging economies where liquidity providers often face a lot of friction to enter and be present in those marketplaces. The reason Nasdaq and AWS have a unique solution jointly for such a challenge, and it's just one opportunity that we have, is that we can use AWS infrastructure paired with Nasdaq trading technology to reduce that friction, to allow global liquidity providers to be present and maintain liquidity and pricing into those marketplaces. That delivers benefits for those national economies, but also to the individual investors that trade. It was 12 months ago here at reInvent that Adena announced, our president and CEO, that we would be moving MRX to the cloud. It was a very exciting moment. It created a lot of energy at Nasdaq and AWS, but also with our clients. We've had many client conversations since then, and I wanted to share with you 3 highlights. First of all, they appreciate the long-term vision. They appreciate the near-term work that we're doing, like we're sharing with you today, but also that we have that vision for the long term, 5, 8, 15 years out. They also appreciate the value creation, the long-term value creation, both for Nasdaq, AWS themselves, but the broader ecosystem. And finally, and perhaps most importantly, they appreciate how considered and considerate we were in our approach. The unique solution that Nasdaq and AWS jointly brought forward allowed us to be additive to the current ecosystem. We didn't disrupt the business models they have, and we ensured that liquidity continued to flow to the marketplaces. As I mentioned earlier, critically important for many reasons. That announcement that Adena made was monumental, but it was just a logical next step for Nasdaq. For more than a decade, we've been working with AWS and moving our surrounding systems to the cloud, something that proved to be very effective and fortunate for us, particularly when we faced 2022 and extreme market conditions. Being able to move and scale intraday meant that we didn't disrupt our workflows or the workflows of our clients. Of course, the reason we're here today, the greatest challenge was yet to be achieved, and that was moving the matching engine to the cloud. Just reflecting on our ambitions, we will make our clients ready. We will help them get ready. We will prepare our clients and our clients' clients. We will modernize and accelerate the transformation of capital markets. We will also invest into innovation, both for ourselves and our clients, and AWS will help us power that. Now, let's talk about why is it so hard to move a match engine to the cloud? Why are we all here today? MRX was the first ultra-low latency marketplace. First of all, like any industry, there's much ingrained technical debt when you're dealing with something that's been built up over decades. As it relates to our industry, latency is critically important, so any physical movement of servers can also be disruptive. So we had to be mindful of that. 100% uptime, resiliency. Many of you out there have that goal, 100% uptime. For us at Nasdaq, it's not an option, it's a must, and that drives additional requirements. Regulation. There's not a capital market on the planet that doesn't have regulation. Here in the US, we're regulated by the Securities and Exchange Commission. That creates requirements. Finally, as I mentioned, it's an ultra-low latency environment. It has billions of messages flowing over it daily. Our clients require us, the regulation requires us, that we have fair and orderly messages flowing over that system. We need determinism, all in an industry where nanoseconds matter. And the reason I know that nanoseconds matter is that our client operations team in Philadelphia will receive calls on a daily basis asking what happened in this nanosecond. With that, I'll invite George to the stage, who'll take us through how we address some of those challenges.
Thank you. Welcome, everybody. As Mark said, my name is George Smith. I'm a solutions architect with AWS, and I have been working for several years now with Nasdaq to move their exchanges to the cloud. I'm going to start with the baseline, just so that everybody in the audience can be on the same page, and then just jump right into the technology that we're using. As many of you already know, AWS is comprised of regions. Regions are geographic locations somewhere in the world where we place availability zones. Today we have 27 regions globally, and availability zones are clusters of data centers where we place storage, networking, compute, and AWS services, and where our customers actually run their workloads. The availability zones are all independent of each other. They are miles apart from each other, so if something were to happen in one availability zone, it would not impact an availability zone that was several miles away. I'm talking about things like floods, power outages, fires, and things like that. We also have local zones, wavelength zones, and AWS Outposts. And as Mark said, Outposts is the solution we're going to spend the bulk of the time talking about. But these three components represent the edge of our cloud. And the entire goal of our edge, which we've been building for several years, is really to move cloud resources closer to our customers. We want to reduce the latency that our customers are experiencing getting to a region. And we also want to give our customers the opportunity to run their workloads closer to their customers. So instead of migrating or running your workload in a region, you could run your workload in a local zone and be a lot closer to your customers as well. And some of our customers do have data residency requirements. Data that's created in a particular country can't leave that country. And if AWS does not have a region in that country, that poses a problem for those customers. So an outpost or a local zone is a solution for those customers as well. So I just want to give a couple of examples, right? So Nasdaq has a data center in Carteret, New Jersey. And if they're running a workload in US East 1, the latency between Carteret and US East 1 round trip is roughly 18 to 20 milliseconds. If they take that exact same workload and they run that in the New York local zone, that latency drops to about 2 or 3 milliseconds, right? And then if they put that on an outpost that's also running in Carteret, New Jersey, latency now is sub-millisecond. And that's one of the reasons that we've started with Outpost as the solution for migrating the exchange. And across this entire continuum of cloud services or AWS services, the operating model doesn't change. The only thing you have to do with your application is launch it in a different location. Everything else stays the same. The launch is the same. The monitoring is the same. Your operations stay the same. It's just where the application is running. So I did say Outpost, and we're going to jump right into Outpost. Here is an Outpost. There will be one in the expo, so you'll be able to go up and look at one as well. It's an industry standard 42U rack. It arrives at your data center. It gets placed on your loading dock, fully assembled and ready to be rolled into production, into position, I apologize. And then the AWS technicians will arrive after that Outpost rack gets there. They will unpackage the Outpost, roll it into position, connect it to networking, connect it to power, and then they'll start a build process. Right? Because once the Outpost has connectivity back to the AWS region, it will kick off a work stream that actually builds that Outpost and gets it ready for use by the customer. Okay. We do have a centralized power shelf instead of individual power supplies and all the components. This solves a few things for us. First of all, it's a lot easier for our technicians to service the Outpost now, because all they do is they slide components out and slide them back in. But it's also more energy efficient and more reliable. And we do have redundant components in that Outpost, so everything that's active is redundant. Despite the name, these are not the top-of-rack switches. It's actually a pair of patch panels, and then your network would come in through the openings at the top of that Outpost cabinet and connect into that patch panel. Once that's done, the Outpost can find its way back to AWS and be able to build itself and then operate going forward. Close up here, we have the top-of-rack switches. You'll notice a few things here. They're in the middle of the rack. You'll also notice that there are two of them. And the reason that we have two is in case one of them fails. It's an active component. It needs to have a high availability built into it. So if one of those switches were to fail, the Outpost would continue to operate, and AWS would dispatch a technician to come in and replace the failed component. This is the power shelf. It is actually built to be highly available. It's in an N+1 configuration. So if one of those cells were to fail, the Outpost would still have power and continue to operate. And here are the EC2 instances. In this configuration, we do have 11 EC2 instances, but when you order an Outpost, you decide how many EC2 instances do I get, what type should they be, what other services do I want included. And AWS will work with you on that order to ensure that you have enough EC2 capacity so that any applications that you're running on the Outpost would continue to operate if one of those EC2 instances were to fail. Turning the Outpost around, we do have a bus bar that distributes the power from the power shelf throughout all the components in the rack. We have a power connector here. There is a second power connector inside the rack. You just can't see it, but it's there. And you would take those power connectors, connect them to two separate power sources within your data center, so that if one of those power sources were to, trip a breaker or fail in any way, the Outpost would still get power from the other power source and continue to operate. The doors on the front and back do close and lock, and you do get keys with the Outpost. We can detect if someone's tampering with the Outpost, so we'll be able to get automated alerts if somebody's tampering with the Outpost. But we can also look at the Outpost and notice that some seals are broken and things like that, and that somebody was tampering with it. All data on the Outpost is encrypted, and it is done so with this security key. This is a hardware security key in the lower right-hand corner of every EC2 instance. It kind of looks like an L on its side. That encrypts all of the data on that EC2 instance. All of the traffic within that Outpost is also encrypted all the way back to the AWS region. And the Outpost is in your data center. So physical security of that Outpost is now a customer responsibility. So you need to ensure that the Outpost is located in a secure section of your data center and that only authorized personnel have access to it. Going a bit into the hardware security key, they're removable. right? So you can remove this hardware security key, and you can see that here we have a circuit board. That circuit board will contain the encryption material for that EC2 instance. They're actually paired to the EC2 instance. We have instructions on how to destroy that circuit board. You basically put a torque screwdriver through that piece of paper, turn the screw comes down and cracks the circuit board. Once that circuit board is cracked, the encryption material is no longer readable, and all data on that EC2 instance is cryptographically shredded. This is how, when we come in to serve service an EC2 instance that has failed, we would remove that security key, we would destroy the circuit board, and then hand the security key to your data center staff. And then your data center staff can dispose of it following their standard e-waste procedures. Then AWS can take that server out of your data center, and you will be comfortable knowing that none of your data is leaving. It's all shredded data. And we will then replace that EC2 instance. So looking a bit at the architecture of what we've been doing with Nasdaq, here we have Nasdaq's data center on the right, we have the AWS region on the left-hand side, and you can see we have a standard outpost sitting in that data center. The outpost is connected back to AWS via the AWS Direct Connect. Direct Connect's not a requirement. If you connect to AWS with a VPN, the outpost can also work with that VPN. I want to point out that all of the orange arrows on this diagram represent the AWS network, and all of the blue arrows represent Nasdaq's network. So the network path between the outpost and applications running in Nasdaq's data center is very short. And that's how we're able to get that sub-millisecond latency between the outpost and other applications that are running in the data center. You'll also notice that in order to get to Nasdaq's data center via that network, we have to go through a local gateway. So that local gateway essentially defines the edge of the AWS cloud at that point. Because on the right-hand side of that local gateway, you're in Nasdaq's data center and Nasdaq's network. On the left-hand side, you're in AWS's network. And I wanted to also point out the Nitro card. I don't know how many people here are familiar with Nitro, but it basically contains a lot of the AWS. We run a lot of our AWS code on the Nitro card, and it really is an interesting presentation if you get a chance to see one, either here at reInvent or even on YouTube. It's really interesting how AWS has developed that card. It's something that we build internally. So with Nasdaq, we're not using a standard outpost to run MRX. We're using something that we've been partnering with them on for a couple of years now, which is what we call internally an ultra-low latency outpost. That's not an official name, that's just what we're calling it. And this outpost has been tuned specifically to run an ultra-low latency workload. With Nasdaq, with the MRX application, we're not running any of the additional services. It's not because the outpost can't run them. The outpost absolutely can. It's just that we don't need them for the MRX design. We are running bare metal compute on this instance. So we have, essentially, it's all compute, and all of that compute is bare metal compute. And what that means is that there's no hypervisor between the application and the hardware. It's just like when you run a .metal instance in region. You get access to the entire hardware, and you can actually tweak with a lot of the hardware settings on the EC2 instances as well. These instances also have a bare metal network, which is this is the first instance that we have that does this. And it's a new instance family that we've been developing for the ultra-low latency workloads. Also, this new instance family is specifically optimized to run the ultra-low latency workloads. You can see now there's a lot more blue arrows in this diagram. And you can also see that the edge of the cloud at this point is now the EC2 instance, because the ultra-low latency network bypasses the local gateway completely and goes straight to the ultra-low latency NIC on the EC2 instance. There's nothing. AWS doesn't have access to that network. We don't look at that network. It's direct communication between the EC2 instance and Nasdaq's ultra-low latency network. The NICs are ultra-low latency NICs. They do take a 1 PPS feed in order to get the highly accurate time required for exchanges. And all of the network cabling within the outposts for that network are equal length. And that means that no instance in that outpost is any closer or any further away from the switches than any other instance. And when we put all this together, we now have an EC2 instance that has an ultra-low latency network, runs standard L2 multicast, fair network cable links, and has seamlessly accesses Nasdaq's existing ultra-low latency networks. I do want to point out that this new instance family is a fully supported instance family within AWS. You build AMIs, which are machine images, the exact same way. You launch them the exact same way. You can monitor them the exact same way. You can use surrounding EC2 services like Systems Manager or auto-scaling groups or host groups the exact same way you can with any other EC2 instance. There are proper EC2 instances within AWS. Now, we've been working on this for a couple of years now, and we're not done. We've just got started. This is the first iteration of this solution, and as people who've been working with AWS for a while know, we always keep iterating. We always create new, we always enhance and optimize and iterate and create new and better solutions, right? So we are going to be doing the exact same thing here. First thing we're going to do is, or I wouldn't say that's the first thing, but on the roadmap is we want to integrate a new chip family from Intel. Intel is releasing a new chip, Sapphire Rapids. It's in some places now, but it's pretty much going to come out at some point over the next year. And when that is available, we're going to create another generation of this EC2 instance family that's going to be based on Sapphire Rapids. We're also going to increase the power available to this Outpost rack. The power today is 15 kVA. We're going to go up to 30 kVA available for this Outpost rack. And the reason we want to do that is we want to enhance the density of the rack. So we pretty much want to optimize the rack configuration, fit as much hardware as we can in each rack, optimize the switch utilization, optimize the data center space utilization with the ultra-low latency solutions. Sorry, okay, and of course, technology keeps moving forward. We expect to be moving forward with that and sort of leading that as well. So we're looking at, with the next generation, we're looking at increased CPU density, more cores within each EC2 instance. We're looking to improve NUMA affinity. We want to improve determinism on that bare metal network. We also want to reduce latency on that bare metal network. And we want to just keep doing what we're doing, keep iterating through and enhancing the service and optimizing the solution so that our customers get the best AWS experience with the best scalability and flexibility that we can offer. Okay. At this point, I'm going to hand you to Nate Sammons, who's an architect with Nasdaq, and he's going to talk to you about the lessons learned during the migration of MRX to AWS.
Thank you.
You're welcome.
All right, thanks, George. So I'm Nate Sammons. I work for Nasdaq in enterprise architecture. I'm going to talk through architectural changes, operating model changes, and then how we've collaborated with Amazon to produce this solution. So first up on the architecture side of things is this concept of static stability, right? So we've got a setup where we've got a Nasdaq data center, right? That's got some Outpost racks in it. It's connected to an AWS region over a direct connect service link. And then obviously there's a bunch of services running in that region, right? So what happens if that service link is cut for whatever reason? Somebody runs a trencher through a bunch of cables or there's an outage of some kind. What happens if there's a control plane outage? What happens if some other service is having an issue, right? We need to make sure that the market is still able to operate, still able to deliver the resiliency that our customers require. And so the solution to that is this concept of static stability, where we make no mutating control plane actions during market hours. Right, so what do we mean by mutating control plane actions? That's any API call into the AWS control plane that will change anything, right? So launching instances, terminating instances, changing security groups, modifying the VPC, any of those things are changes, right? And so this is sort of the system has inertia. It will generally continue to function if you don't touch it, and so don't touch it during the day unless you really need to make a change, right? That's this concept of static stability. The other thing that we plan for is disconnected operation, right? So even if that service link is cut, we need to make sure that all the systems that are in the outpost in our data center continue to run, right? We need to make sure that they don't require constant communication with the region, just because we, again, we need to maintain essentially 100% uptime on these systems. And then we use long-lived SSL certs. This is kind of an easy win, right? Because I think expired SSL certs is probably the #1 reason for outages at this point. So this was just an easy thing for us to do, right? We have long-lived certs and we rotate them relatively frequently so that even if there's an outage, right, the cert isn't going to expire during the span of that outage, right? And then we have very careful use of AWS services, right? So George had mentioned that we're essentially just using EC2 in this case. We use, of course, the local gateway for break glass access. That means that from the local Nasdaq network, we're able to SSH into these instances without going through the service link and without coming down through the direct connect or anything. Again, just as a break glass procedure in case we need to get in. We use local boot on those EC2 instances. This did a couple things. It let us reduce the complexity of the overall system, right? So fewer moving parts means fewer things that can break. And then it also let us pack more of those bare metal instances into each rack, right? Because we have a very dense solution for how these markets operate. And then in general, we did a deep dive on regional dependencies with all the different service teams for the services in use for this project. And that went all the way down to examining things like the EC2 metadata service that runs on the Nitro controller to make sure that it doesn't require access into the region, to get instance roles or any kind of metadata off of that service. So really, it was talking with individual service teams, making sure that we understood all the different failure modes, how those things operate in cases of disconnection or in cases where there's some kind of misconfiguration or whatever, right? Just a lot of deep investigation with AWS. So then moving forward, we've got this concept of fault domains, right? This is not new to us or to anybody in the room, hopefully, but again, we've got a data center. It's got an Outpost rack in it, a couple EC2 instances with our applications running on it, right? So physical servers can and do fail, right? And so every Outpost rack that we have in our data center has a hot spare. That is a fully provisioned EC2 instance ready to go. We can move workloads onto those instances intraday in case there's a machine failure. And then, of course, racks are also a fault domain, and so we have multiple racks. Each of those racks have a hot spare provisioned as well. And then we use this concept of a logical outpost, right? This is really just so that when we're discussing this with customers or other people, once we get more than one rack in an outpost, we think of it as a logical outpost because it's a resource pool that spans all of those different racks. And so an outpost is not just a rack, it's a set of racks in your data center. We run A/B pairs of every component in our system. And we make sure that those A/B pairs fall on different racks, right? So the whole concept of fault domains is that you don't want to have your A/B pairs in the same fault domain, right? So this is all, fairly straightforward, but we split up all of our workloads so that different components run on different racks to make sure that we've always got a good solution for any kind of outage. Of course, we're adapting this particular solution to the public cloud. But a lot of the public cloud concepts really map down into the Outpost anyway, right? So you can sort of think of each Outpost rack as an availability zone, right? They're obviously much closer to each other than AZs are. We've got, a couple hundred nanoseconds between racks instead of, a millisecond or whatever between AZs. But we've really just kind of mapped a lot of these different concepts down to the Outpost rack setup to make sure that we can maintain resilience. So then as we kind of zoom out from the individual racks and a set of racks, if we look at a kind of a higher level diagram, we've got, of course, our data center. It's got a logical outpost with a few racks of hardware. That's connected to a primary region running the EC2 control plane. Of course, data centers are also failure domains, right? And so we have a DR data center in another location, well far away from our primary in New Jersey. That's connected with Nasdaq's WAN, which is itself a multiply redundant network connection between those facilities. In that DR facility, we then run another logical outpost composed of multiple racks as well. And that outpost is then homed to a separate region, right? So each outpost is assigned to a specific availability zone in a specific region. That's where it gets updates, where it gets telemetry, all kinds of other things. And so we've split up our system so that we've got these multiple different outposts running in physically separate locations. Each one is paired to different regions, and each one is owned by a different account so that we can really make sure that we've got hard bounds around all of these different systems for blast radius purposes around outages or around break-ins or whatever happens. And then, oh yeah, I forgot to click the button there. Moving forward, talking about the operating model, we really took this opportunity to rethink how we do critical systems at Nasdaq, right? And so, again, we've got Outpost Rack. That's got these EC2 bare metal servers that George had talked about, running EC2 servers on top of, essentially. Those are connected to the control plane, right? The first thing that we had to do was transition from PXE-booted images on our legacy servers to AMIs, right? Obviously, all of the services and systems in the Outpost are provisioned and managed through standard AWS APIs, and so we had to make a transition from the images that we build for our legacy systems to an AMI. And that facilitated a bunch of other adaptations, right? We rely on automation from GitLab and Terraform to both build those AMIs as well as provision all the EC2 instances, in the racks, provision the VPC network, all of that stuff, right? Everything should be automated all the time. We use dedicated hosts on Outpost. This is a really important topic here because, I had mentioned that we have A/B pairs of all of our components. Those A/B pairs need to run on different racks, and we need to know that when we launch a particular instance onto a particular machine that we know what rack it was in, what position it was in. We have a number of performance tuning aspects that we've done so that we really plan out exactly what's running essentially on every core of every server in this entire installation. And so dedicated hosts, along with some API improvements from AWS, allowed us to directly target a specific server in that Outpost rack to make sure that we understand exactly what workloads are running everywhere, right? We don't just treat the entire Outpost as a resource pool that we run things on, right? The nature of our workloads is such that we need to be very careful about what's running where. And then, of course, we had to adapt our hardware lifecycle, right? So again, physical servers and components can and do fail, and so when we have a server that has an issue, we need to understand how to get AWS personnel into our data center to do the swap, how to make sure that we have all the policies and procedures around escalation and all of that kind of stuff. That wasn't a big deal to change. It's just that it's one of these things that you need to do as you're moving critical workloads onto this kind of platform. And then, of course, we tested and tested and tested and then tested some more, right? Part of this installation, right, we need to make sure that things maintain resiliency when the service link is cut, right? So we would pull power from a rack of Outposts, we'd down individual machines, make sure the overall system works. We'd cut the network connection, right, not physically, but we'd turn off firewall rules and that kind of thing to make sure that the Outpost, when it was disconnected from the region, continued to operate and we could continue to get in through that local gateway. All of this stuff, right, just test over and over and over again. Tear down the entire system, rebuild it from scratch, make sure that everything is working the way we expect it to. And then we did a bunch of drills with AWS support on what Amazon refers to as game day scenarios, right? This is really so that as it's a deep partnership between Nasdaq and AWS, we need to understand that if there's an outage, we have the escalation paths. We know the right people are getting paged on the Nasdaq side. The right people are getting paged on the Amazon side. We are obviously a highly regulated entity, and so we have very stringent reporting guidelines with the SEC and other regulators around the world. And so we need to make sure that if there's an issue, Nasdaq is able to detect it. We're able to get the right people on a call, able to solution that issue, immediately. And Amazon has really just been a great partner in this entire thing, right? We wouldn't have been able to do any of this without Amazon, obviously, and it's just shown how deeply that partnership goes. So with that, I'm going to talk about collaboration, right? So This entire project sort of kicked off back in 2018. We had a kickoff with AWS to just start to think about what would it mean to run an ultra-low latency critical workload on AWS, right? This was a little bit before Outpost was really named Outpost. We were also able to get access to early Outpost hardware in an AWS lab just to start kicking the tires, looking around, at the bare metal instances, make sure that we could get in and do the right things and make sure that the solution was really gonna work for our needs. And then in 2018, of course, AWS announces Outpost as a product at reInvent. 2019, we were able to get a custom Outpost with ULL hardware into our lab. That's a really important step as well because we've got very high performance network monitoring tools that allow us to measure latency, down to the nanosecond, and we needed to make sure that this solution was going to meet our needs from a performance and latency and throughput kind of perspective. 2019 was also a time when we, Nasdaq, had really figured out that cloud is really where everything is going, right? And so we kicked off a RFP process where we decided to move some of our markets to a cloud provider, and then we needed to figure out which was the right cloud provider to do that with. So we ran a pretty extensive RFP process, obviously picked AWS as our partner there. And then later in the year, Outpost was also went general availability at reInvent as well. In 2020, we got our first custom SKU with ULL hardware. The difference here is really that the previous Outposts that we had were kind of one-off test rigs where we would get it into our data center or it would be in an Amazon lab. We were able to figure things out, but it wasn't something that we could really mass produce for our own needs or for the needs of our customers. And so 2020 was the first time we were really able to exercise the AWS factory to produce a fully customized ULL Outpost through the quote regular channels of how they build Outposts. Then in 2021, obviously, Adina Friedman, our CEO, announced that we were going to migrate MRX to Outposts, and everybody got working on that project pretty quickly. The first half of 2022 was spent doing various hardware revisions, right? We landed on the correct production CPU spec, the correct setup for NUMA on the motherboard, which is very important for our latency and determinism needs. We got the right setup of ultra-low latency network cards and switches and all of that other gear, really just assembled into a working system. We were able to deliver our production hardware into our primary facility and into our DR facility, as well as do customer testing, performance testing, a number of other things, right? And before we finish, I want to mention that in over 2020 and 2021, right, we obviously had the COVID pandemic. That affected supply chains globally, and a number of components involved in this solution became very scarce. And so we were able to leverage AWS's deep supply chain with a variety of vendors to actually deliver this solution without any delays, even though there was a pandemic, even though there was a bunch of supply chain issues. Then, of course, in 2022, just a couple weeks ago, November 7th, we launched Nasdaq MRX on AWS Outposts. The November 7th, we did our first launch with a small set of symbols, and then on the 14th, we cut over more symbols, and this coming Monday, December 5th, we are cutting over the rest of all the symbols and will be fully live on this platform. But it is live in production right now, trading options on this venue on AWS Outpost. So now, we want to talk about the future.
Thank you, Nate. So a great overview from George and Nate. And also we have to say that there's been a lot of people involved through all the steps that Nate just took us through, and we thank those people. AWS and Nasdaq working together is a really powerful combination. And I think George said it. What you've seen today is where we are today. But we're going to do a lot more. Every day, every week, every month, every year, we'll progress this schematic and the products and services that we can offer. So to have a little insight into that, I'll hand to Nate, who will take us through the technical future, and then I'll come back and share with you some of the product aspects.
Thanks, Mark. So as we talked about with George, we've got a tech roadmap for Outpost that is mostly denser, faster, more components, more servers, next generation hardware, et cetera, right? That's going to continue on into the future. We've got a plan to migrate more Nasdaq markets, as well as hopefully customer markets, onto this next generation Outpost platform. We want to do more dynamic deployments, right? I had mentioned that we do these very careful planning sessions where we understand exactly what process is running on every core of every CPU in every server in that entire system. That's planned out very carefully, right, for performance and latency reasons. We want to get to a system where we can give it more constraints and the system will self-assemble into the correct configuration, right? That's going to really help us as we progress towards running markets in local zones and in the public cloud, but it's really a big step for us to go just because of the latency concerns and the resiliency that we need to have out of these kinds of platforms. We do want to integrate more services, right? So we had said that we're very, very careful with this platform about the set of AWS services that we use. EKS and RDS are kind of top of the list of things that we want to integrate next. But we're gonna continue marching down that road just in a very careful and stepwise fashion, right? Again, we need to meet regulatory burdens. We need to meet our customers' needs. We need to make sure that it's resilient and has 100% uptime, et cetera. But we are gonna continue to add more services. And then, of course, our goal is to be able to run markets in AWS Outposts, in local zones, and in regions, right? Some markets will continue to be on Outposts. Some will run in local zones. Others will run in the public region. But that's really where we want to go, right? We think the cloud is obviously the future. That's why we're here in Las Vegas talking about all of this at reInvent. That's really where we want to go. There are some very serious technical concerns with how we could operate this sort of system in the region, but we had those same concerns with this Outpost setup, right? And so in 2018, we didn't really know if this was going to work, and today we're in production. So this is kind of where we're going and what we want to do.
Thank you. So now we'll talk a little bit about our product roadmap. First of all, the collaboration with AWS will continue. It will deepen. We're only getting started. We've said that a number of times today, but it's very important. We have so much more work to do, so much more opportunity, and so much more value to create together, not just for Nasdaq and AWS, but for the industry and for capital markets at large. During next year, we'll bring to market a co-location in the cloud product. Basically, that would be a version of Outpost, similar to what you saw earlier today, that will be placed in proximity to Nasdaq match engines and will allow clients to seamlessly connect and be in proximate location and leverage the services from AWS. We think pairing the proximity and AWS capabilities will be intriguing and a value add for our clients, both those we have today and the ones we haven't met yet. We'll also be bringing a private local zone online in the next couple of years. This will be a brand new structure in our data center campus, NY11, and it will be the first private local zone specifically designed for capital markets. Again, providing clients choice that is additive, allowing clients to interact with Nasdaq in a new way. Finally, I've talked a lot about the 30 exchanges that Nasdaq owns and operates, the 130 that we power around the world. All of this will be available to them. All of the technology, all of the advancements, the blueprint that we create will be available for our clients around the world. And we're very, very excited for them to follow our journey and then also implement their own journey to unlock the value that we're unlocking. I very much appreciate the time today. I thank George and Nate. Feel free to connect with us on LinkedIn or come by and say hi. Again, thanks for the time and have a great evening.